Number 40. The existence of the dwarf planet Pluto was proposed based on irregularities in Neptune's orbit. Pluto was subsequently discovered near its predicted position, but it now appears that the discovery was fortuitous because Pluto is small and the irregularities in Neptune's orbit were not well known. To illustrate that Pluto has a minor effect on the orbit of Neptune compared with that, with the closest planet to Neptune, letter A, calculate the acceleration due to gravity at Neptune due to Pluto when they are 4.5 times 10 to the 12 meters apart, as they are at present, and the mass of Pluto is 1.4 times 10 to the 22 kilograms. All right. So remember, guys, we have this nice formula. We've developed this in several questions prior, I think in like 33 or 35, and a few more before that. So just remember that the centripetal acceleration is equal to the gravitational constant multiplied by the mass of the planet that the gravitational acceleration here is due to, divided by the radius between the two planets squared. So, for example, if I'm trying to find the acceleration due to gravity of Pluto, meaning the acceleration due to gravity due to Pluto, okay, then I need to know the mass of Pluto. All right, so these should be consistent, all right, meaning in terms of, not in terms of number, but in terms of concept. So I got this result basically by just substituting this value on into this equation, and then these masses would cancel, okay? But I spoke about y and everything in detail in other videos. So let's just plug it on in from here. So the centripetal acceleration will be equal to the gravitational constant, which is 6.673 times 10 to the minus 11, multiplied then by the mass of Pluto, which was 1.4 times 10 to the 22, and that will all be divided then by the distance that they are separated by, 4.50 times 10 to the 12 squared. And all we have to do now is just simply plug it in. So this is for letter A. So 6.673 times 10 to the minus 11 times 1.4 times 10 to the 22. Divide that by 4.5 times 10 to the 12th squared. And we get a value of 4.61. 4.61 times 10 to the minus 14 meters per second squared. It's a very, very small centripetal acceleration. All right. So now let's take a look at letter B. Letter B says calculate the acceleration due to gravity at Neptune due to Uranus, presently about 2.5 times 10 to the 12 meters apart, and compare it with that of Pluto. The mass of Uranus is 2.62 times 10 to the 25 kilograms. All right, so let's do part B over here. I got a little more room. So again, it's the same formula. Centripetal acceleration will be equal to gravitational constant multiplied by the mass of the planet causing the acceleration divided by their distance squared. So this will be 6.673 times 10 to the minus 11 times the mass again of Uranus this time. So it's 8.62 times 10 to the 25. And that is all divided by then the distance between the two planets, and it told me that it's 2.50 times 10 to the 12. Don't forget to square it. And then the centripetal acceleration simply is 6.673 times 10 to the minus 11 multiplied by 8.62 times 10 to the 25th, and divide that now by 2.5 times 10 to the 12th squared. So you get a value of 9.2 times 10 to the minus 10, and that is meters per second squared. Okay, so I mean, not much at all either. Whoops, not much at all either, but definitely, I mean, it's fourth, well, not four, but it's 1,000 times, no, excuse me, 10,000 times more or stronger than Pluto, right? So now it says compare it. So why don't we just take then the larger value? Whoops, why is it doing that? Why don't we just take the larger value here and then divide it by the smaller value? So we'll find out what the ratio is, right? So we'll do 9.2 times 10 to the minus 10, all divided by 4.61 times 10 to the minus 14. And let's just find the quick ratio here. So 9.2 times 10 to the minus 10 divided by 4.61 times 10 to the minus 14. And it comes out to be Yeah, 20,000. So I said it'd be a little more than 10,000, right? So it's about 20,000 20,000 to 1, all right? So Uranus's centripetal acceleration is 20,000, times greater than the centripetal acceleration due to Pluto. Guys, thanks so much for checking us out. Please remember to subscribe and look forward to helping you with the next question. Take care.